Welcome, everyone. I will present myself, Samuel Ali. I'm assistant professor in the University of Technology and Applied Science, College of Applied Science in Ibri in Oman. Originally, I am from Tunisia. I will present my work entitled Resolving Code Smells in Software Product Line Using Refactoring and Reverse Engineering. It's just we will present the content as you can see in the outline. We'll present the background, the motivation, some research objective, some related work, and our approach. But it's just the beginning of the approach. We are just trying to find the appropriate tools to implement our approach. Okay. We'll begin by presenting the context of software product line. In the beginning, people are trying to develop one software, but the strategy in the end of the 90s changed to try to define a set of software, not only one product. Here we have some definition. A software product line is a set of software products that share a common set of features in a prescribed way. We have a set of products sharing some characteristics and some behaviors, but having some other differences between them. Product line technology builds family of products exploiting some common core asset and managing their variability. The main concept in software product line is the variability between the different products. Here we have many kind of software products. The operating system Linux, one of the initiator of the concept of product line is Nokia in the beginning, to provide a large number of telephone or smartphone during the same year. Okay, another kind of product line is the cars and the software inside the cars. Okay, to explain the context of software product line, we have, like you can see here, two products, product A and B. We have some common core. The common core in both of them, product A and product B. The common core is the common structure, common assets, common behavior, and the specific parties will be this FA and FB. That's why we have some core asset and some customized assets, and we can develop in this way the product instance of each one of the products. Here we have product A and product B. This is an example of one of the main model used for defining a software product line. It's the feature model. Here we have a concept. The main concept is the car, and we have here many features. Inside, we have the transmission, the horsepower, the air conditioner. As you can see here, we have some mandatory features and some optional features, as you can see here in the representation, as mentioned in the legend. Okay. The same thing here, we can define the different alternative features. In this way, we can define any instance of the car using this model. We can have a car with a manual transmission and the horsepower without any air conditioning. In the same way, we can have a car transmission automatic with horsepower with air conditioning. This model allows us to get different kind of product. Okay. To define a product line, we have two strategies, top-down or bottom-up. from top down, the purpose here to define the line, the product line, and after that we will define the details, the different products we can get from the product line. And we have the bottom up, we have some products, and from this list of products we can get the main product line. Okay, we have some products sharing some core assets. We will identify them as composing a product line, and we will define this product line using this bottom-up strategy. As you can see here, we have a top-down approach. We'll define the product line architecture, as you can see here, and after that, we can instantiate the different kind of product, as you can see here, product 1 and the product 4. Here we have in software product line engineering, we have two main words: the domain engineering, where we will define the software product line architecture, and the application engineering to obtain the appropriate configuration and the appropriate product in the end. Okay, this is how to define our product line. This is the main architecture for the product line with some variability. As you can see here, the red rectangle are the software variability. The other part are the common features. As you can see here, we will find them inside all the products. For the variability, for the software variability, sometimes we can find some features. As you can see here, we have only one variable feature. Here we have 2, here we have another one, as you can see. From one architecture, we can have an infinity of possibilities. Okay, the second approach is the bottom-up approach. The bottom-up approach, we have a list of products, we have a source code. We have a source code, and we can identify the model of the product line in the end. We will identify the different feature composing this product line. This product line, how to do this? By some product abstraction, we will identify the different products, the different classes inside the source code to identify the different features present inside the common part, the variable parts, and so on, by the feature identification. And after that, we can make the design for the feature model for the entire product line, as you can see here. In fact, in our paper and our work, we used this bottom-up approach. We used this bottom-up approach to get a product line model from an existing source code. As we mentioned, we are going to face some problem inside this source code. We can face some anti-patterns, some code smells. In software engineering, we have some practices. We can define the good practices as the design pattern. We need to have inside our design some typical solution to some common problems. This design pattern are describing some standard solution. We can make adapt this solution to our needs or to our requirement, depending from the situation. For the bad practices or anti-pattern, it's some common mistake we can do it as a developer. Some bad programming practices. Some generally we name or this anti-pattern as the code smells. The code smells can be defined as some bad software design practices leading to some defects in our source code, more complexity, more difficulties to maintain, or some purposes, some issues related to scalabilities. Some of the code smell are related to method, to classes length, to the non-respect of some object-oriented programming principle, to the coupling between the classes, the increased level of coupling, and so on. Okay, one of the definition is the code smell are some structure in the code that indicate a violation of fundamental design principles and have a negative impact on the quality of the design. Okay, we have some problem in our design. That's why we need to try to find a solution to it by using design pattern or to resolve the code smell. Maybe we can, sometimes we don't need to use the design pattern, but we can make a solution using the design pattern. Okay. Here, some example of code smells. We have the duplicated code. It's a bad quality of the code. One of the anti-pattern is the duplicated code. It's to find the same piece of code in multiple places inside our application. This kind of code can be recognized as a feature in one program. That's why we need to resolve this problem before trying to identify the different feature for our software product line. It can be in the same class, in different method. As you can see here, we have the same piece of code, the same loop inside the same class or the same method. Okay, another code smell is the larger class. A larger class, as you can see here in the picture, this larger class is doing a lot of things. Means that the class is trying to do too much, too many variables and method. Okay. In this way, we need to resolve this problem, reducing the size of the class. Another one is the long method. In the same way, it's a method with a lot of instruction inside. It's difficult to maintain, difficult to understand, to modify, to extend. We need to reduce the size of this long method. The same thing, another code smell is the long parameter list. The long parameter list, as you can see here, we have a lot of parameters. As a developer, we need to focus on the different parameter to put in for the method, the data type, a lot of things, a lot of concern for the developer. Here, the anti-pattern long parameter list concern a list of parameters of a method that is too long and therefore difficult to understand. Difficult to understand for a developer. We need the documentation to understand the method and so on. Okay. And the last one we presented here is the deadlock, but we have more other code smells. Here the deadlock is a variable or parameter or field method class no longer used. As you can see here, we have a section of the code, a branch, which is never executed in this program. Okay, here we have A equal to 1, B equal to 10. We make a verification if A greater than B. As you can see here, never in this condition will not be true because of the initialization of the values A and B. In this way, this part of the code will be a dead code branch. Okay, here some of our motivation is to define a product line, the automatic construction of the product line from similar products to identify the different features, the common features, the variability inside some source code. Another motivation is the automatic identification of the features from the code source to build and to construct the model features, identify the asset and the construction of this asset, and how to reduce the different code smells we can get in the source code in the obtained product line. The purpose here, if we have problem inside the original code of the different product, the obtained product line should be a clean product line. A clean product line. Here we try to obtain a product line without this code smells identified in the original products. Here our approach will be to detect. In the beginning we have a source code. We name it here a dirty code. We have a dirty code with a lot of code smells. We will try to clean this code. Here the purpose of the code refactoring is to detect and eliminate the code smell, refactoring the variant code before extracting the features, before doing anything related to our software product line. We need in the beginning to clean the code, and to have in the end a product line free from the bad practices. We have in the literature many related works. Apple proposed bad smell specific to software product line called variability smell as an indicator of existing or undesired property. Another work is related to how to propose a method to derive metric threshold for software product line to identify potential problem in feature implementation. Abelio proposed means to detect 3 code smell in feature oriented programming code, performing some study to detect code smell in a software product line by using some metrics. Another work is investigating the code anomalies in the context of software product line and proposing a new detection strategy. All this work are related to identify problems in some source code. We presented only the works related to software product line, but we have many works related to identify code smells in the code and making refactoring. Okay. We have also some academic or professional tools for detecting and correcting the code smells, like Shake Style, Decor, iPlasma, Infusion, G-Deodorant. Some of them are some plugins of Eclipse. Some of them are commercial tools. Here we have Check Style, was developed to help programmers to write Java code, meeting the standard coding and it's able to detect some code smells. Not all of them, but some of the code smells. Here, the second one is a tool for detecting different code smell, including the long method, the long class. Another one is used for evaluation of the quality. Infusion is a commercial solution to make the refactoring for source code in Java, in C, in C++, so on, and to detect 22 code smells. G-Deodorant is an Eclipse plugin that is going to identify code smells and proposing an appropriate refactoring in Java programs only. Okay, just here we will, our approach is just the beginning of our work. As we mentioned in the beginning, we will try to exploit some code source, software product variants. We will try to detect the anti-patterns, trying to refactor this code and to obtain a clean code. A clean code here, the purpose is this. In this part, we are using the refactoring to obtain clean code and to resolve the problem related to code smells. After that, we will try to identify the different features. The main work is to identify the common features and the variable feature, and to build the feature model in the end. To do this, we are opting to use the Yago This Yago is an ontology formed by a lot of knowledge related to information from Google, from many sources, allowing us to obtain the relationship between the concept and so on. This, we will use the Yago using some queries for this ontology to make some partial identification. We can increase the quality of the identification using some artificial intelligence algorithm to make the global identification. But sometimes it's possible to identify the different concept using the Yago only without any need of optimization using the artificial intelligence algorithm. Okay. After extracting the different features, we are going to identify the common set, the optional set, the mandatory features, so on. The purpose here to make the analysis of the different features and to identify the characteristic of our feature model, to extract the root feature, to extract the different atomic feature, the relation, the alternative, the or inclusive, the or exclusive, the and, all possible features inside our product line and all the relationship between them. In any feature model, we can find some constraint, require or exclude. Sometimes one feature can exclude another feature, and in the same time, one feature can require another one. Okay, this is our approach presented inside the paper. As I mentioned, it's just the beginning of the work. Now we are trying to find the appropriate tools to implement the refactoring. To implement the refactoring, we are opting for a source code related to Java, Java source code. And after that, we will try to define our queries using the Yago ontology. In the end, the main purpose is to obtain the feature model of our software product line. To conclude, software reuse is an important challenge in software engineering. One of the purpose of software product line is the reuse. Why the reuse? Because as we mentioned, the product are sharing some common part. These common parts are going to be reused in some products. The software product line is one of the techniques used to ensure the software reuse. As we mentioned, the derived product can contain some problems called code smells. To resolve this, the refactoring is a solution for us. Refactoring can improve the internal structure of the software system. We can combine refactoring to eliminate the code smell and the reverse engineering to propagate the modification to the design level. As we mentioned here, the reverse engineering is from the code. We will obtain a design model. That's why we speak about combining the refactoring in the beginning to obtain the clean code, and the reverse engineering to obtain the design of the software product line. Okay. Our future work will be related to make the choice of the appropriate tool to use in our prototype, to compare the proposed tools in the literature, to identify some fields of activity, some programming language. In the beginning, we will begin with Java, but we can focus on extending our works for other programming language to identify. As we mentioned, the code smells is a large number of code smells. we need to decide which one of the code smells in the beginning we need to resolve. After that, we will define what kind of strategy we'll opt for, detecting only the code smells or detecting and correcting. But normally, to obtain a clean code, we need to opt for detecting and correcting the code. The last one is to identify the correct way to how to combine many of these tools. As we mentioned, we have existing tools. We'll try to combine them to reuse existing things and to not have to rebuild the well. Okay, in the end, one of other future work will be the refinement of the approach. As I mentioned, this is draft of the approach, but this approach can be optimized to something more better. Okay, thank you for your attention.